Hello, good morning. Let us to introduce ourselves. My name is Muhammad Julian Reza.
My name is Rian Hanafi.
My name is Muhammad Rizky Akbar.
My name is Riduto Mutasi Harjo.
Hello, my name is William.
Purpose of this video, we will explain the mechanical function of elevator at ICT building Diponegoro University Semarang.
Elevator is a vertical transport used to transport people on a track, usually found in high-rise buildings. Based on the Fock principle, elevator is divided into two kinds of categories. The first one is hydraulics, using a hydraulic system in which elevator are lifted like using a jack. On the second one, traction elevator is using a cable or steel strap or regular, where the ground is lifted instead of being used from the bottom.
Main elevator component. The main component of the elevator consists of two large parts, engine room and cell houseway.
Engine room is the most important room, where the room is the happening of all process of operation if elevator take place. In the engine room, there are several elevator rooms.
Motors. This elevator motor has a power supply back and forth AC from the PLN is very important in the implementation work of elevator. This motor driver has the ability to rotate between 50 radians per minute up to 210 radians per minute, with a motor voltage capacity adjusted to the carrying capacity. This motor driver is equipped with magnetic brake which holds the motor when the train has reached the intended floor. The movement of the elevator, when it fast or slow, is regulated by PLC, Programmable Logic Control. The motor driver, when it pulling and lowering the elevator, uses a circular rope on the pulley of the machine. Governor. Governor is the main driving element in the elevator. In the governor, there is a switch that serves to disable or circuit so that the elevator automation is off and not working. Besides, the switch also has a brake hook. This brake hook used to stop while sailing and then pulling the brake on the elevator or train.
Panel. Panel is a class of automatic elevator control. In this panel, there is a motor elevator and logic control program that used to adjust the motion of the elevator.
Sled is the place where the elevator operates in the floor of the vertical alley. In the place, the elevator reaches the floor.
Train or cage. The elevator train operates in the sled and treads on rail in either side. In the right and left side there is a guide rail that used to guide or climb rail. In addition to rail guide, there is also a rubber silencer to reduce the shock when the elevator stops and starts to start. There is also a load detector contained under the elevator rail. At the elevator railway doors, there is also a safety ray and safety shoe attached to the railway door and serve to prevent elevator passenger from being pinched in the elevator door. Inside the elevator railway as well as the 4 buttons to be targeted by user elevator. Counterweight. Counterweight is usually mounted behind or next the elevator train. The weight of counterweight must be in accordance with the provision that exists. The factor that determine how weight of this counterweight must include the weight of the train, the full capacity of the train, and the balance factor. How elevator works. Elevator construction in the form of a cage, a raised train is lowered by a traction machine. By using a tensile steel strap through a sliding space inside a building specially made for elevators or hoistway. In order to sway the elevator train, use high-speed guide rail tied with this elevator slideway. To compensate for the weight of the carried and load is used a counterweight. Counterweight is equal with weight of the train plus half the maximum weight load. This is to lighten the traction machine work, because when the train is filled with the maximum load, the traction machine only attempts to lift or raise half of its maximum load. Conversely, when the train is empty, the traction machine only needs to lift or raise half of the overload maximum load on the counterweight. The elevator cart is hung in the sled by some steel hoist rope, usually using two pulleys and counterweight. The weight of the train and counterweight produce adequate traction between pulleys and hoist ropes so that the pulley can hoist the hoist ropes and move and hold the train without excessive skid. Trains and counterweights move along the vertical rails to keep them from swaying.